set of notes that we're going to go over this morning is 1.1. So 1.1 notes talked a lot about functions. So a quick reminder that we know that something is a function. I use the definition of a function is also the best life advice that I have, especially for people your age, and that is so both the definition of a function and my best life advice for you guys is no repeating x's. No repeating x's. It's my best joke all semester, so I hope you laughed. So here, when we're looking to determine whether or not a table is a function, we just need every x value to be unique. Y values can be whatever they want. Y values are allowed to repeat, x values are not. So here, is this a function? 110, 13, it absolutely is. Is this a function? 110, 10. This is not a function because the 10 repeats. Is this a function? 110, 13, yes it is. So again, deciding whether or not something is a function, the y values don't matter to us. We're only concerned about x's, and all of your x's have to be unique. No repeating x's. Okay. The next one says the population P is a function of the amount of garbage G produced by a city. G is measured in tons per week, and P is measured in thousands of people. The town of Tola has a population of 45,000 and produces 14 tons of garbage each week. Express this information in function notation. So the population is a function of the amount of garbage. So that would mean that G of X or G of P the town has a population of 45,000 and produces 14 tons of garbage each week. Express this information using function notation. This question is written really weird. So they want function notation, which means that they're looking for some kind of f of x. But here, if it's garbage and people, then it's going to be G of P. So I'm not going to lie to you right now. I'm cheating and I'm looking at the answer. That way I know what it is. I don't want to tell you the wrong thing. I did this wrong. There we go. I want to make sure that I'm telling you the right thing, mostly because I just don't like the way this is worded. Here we go. Oh, okay. See, so then if we were writing function notation, it would be something like G of P equals and then a function, but they don't really give us enough information for that. So instead what they want is the population of 45,000, but you see how it says P measured in thousands? So then 45,000 would be 45. A population of 45,000 produces 14 tons of garbage per week. So that's how they want you to do that one. Glad I looked it up because I definitely wouldn't have said that. Okay, and so then next, remember that if you have function notation like this, which is what I thought they were asking you to write on the last question, and you're asked to find a value, we're just going to plug these numbers in for A. So K of -5 would be 6 times -5 squared minus 4 times -5 plus 4. K of -4 would be all of that, but with a -4 instead of a -5. Remember, all you do if you want to pull up your last thing like that is second and then enter. And so now I can change my -4s to zeros. Oops. Change them to 2s. So that's 174, 116, 4, 20, and 134. Okay. So just plug in. Okay. Here we have m of x equals 3x minus 5. M of x equals 12. So here they didn't give us x, they gave us m of x. So I'm not going to replace x, I'm going to replace m of x. So I'm going to make this 12 equals 3x minus 5. Add the 5. (17) divided by 3. So that's what I'm going to put in for my exact answer. And rounded, that is 5 point, how many decimal places? 1, 2, 3, 4. Okay, so again, they didn't give me x, they gave me m of x. So I didn't replace x, I replaced m of x. Okay, so make sure you're reading carefully. All right, so when we're given a table and we want to find appropriate values, here they gave me w of 25. Keep in mind that the number inside the parentheses are t's. So find 25. That means that w of 25 is 23. And now again, here they didn't give me x, they gave me h of x. So that means I was looking for where is h of x 24, and h of x is 24 when x is 17. Okay. Now, when we're looking at graphs of functions, we want a graph of a function to pass the vertical line test. And the vertical line test means that I cannot draw a vertical line that would touch my graph more than once. I know you guys are probably familiar with the vertical line test, but this would pass, this would not, this would pass, this would pass. Now, to determine whether or not something is a one-to-one function, one-to-one functions map exactly one x to exactly one y. So a one-to-one function means that x's are unique and y's are unique. So to determine if a function is one-to-one, we use both the vertical and the horizontal line tests. So if it passes the vertical line test, it is a function. If it then passes the horizontal line test, it is a one-to-one function. Okay. So for example, here, this would pass the vertical line test and it would pass the horizontal line test. So yes. But if we look at the second example here, it would pass the horizontal line test, but it would fail the vertical line test, which means that it is not a function. And this is very specifically asking me which one are one-to-one functions. Okay, the next one would pass the vertical and would pass the horizontal, so yes. And the last one would pass the vertical and would pass the horizontal, so yes. Okay. Last but not least, for section 1.1, if we're trying to find points from graphs, P of 4 still just means where is X or V, in this case 4. So go to 4 on the V and then find your graph and its corresponding Y. So since this point is 4, 2, that means P of 4 is 2. And now again, we got to be careful here because they didn't give me X, they gave me Y. So this time I'm going to go to 3 on the Y and find my graph. And this point is 1, 3. So when Y is 3, X is 1. Or in this case, when H is 3, V is 1. I don't know why more feels like it needs to change those letters. Any questions on anything from 1.1? Yeah, I mean, the good news is we start out pretty easy, I think. This section was relatively easy, and it's stuff that most of us remember. And it's not a lot of algebra. It's just properties, and properties that you usually remember. All right, so I'm going to stop this one.